this command was generating a
In not so
default.
stubby area, yeah.
Yeah, so basically that's a main purpose of this command, to generate the default dot, right? And this is the one way that you can generate the default in the NSC area. Another way is what we have. So you can use this command, rado respect one default information originate, right? So you can use this command to generate the default, but make sure that for this command, you must have default route in your RIB. Which one? Like, for example, like this way. You must have a default route. Then the
Yeah.
OSPF will generate a default route in your routing table, in your OSPF table. But another way, what we have, same command, right? So instead of you can use the always. So in this case, no need to have default route in your RIB. Do this lab from your end. Let me know if you have any questions. Like, so we have covered the lots of part in your, what we call in your OSPF protocol, right? So now tell me one thing. You have done with this protocol, right? OSPF protocol. What is the problem that you have find in the OSPF protocol? So as I already told you that, right? So this batch is not only for the CCIE SP, right? We are also going to cover the CCD part, design expert, right? So what is the problem that you have faced in the OSPF?
Well, so far it's looking it's the good one, but
Okay.
can't answer where is that.
Not that
It
much
looks good.
scalable.
Scalability issues?
Looks like I can say.
Yeah, exactly. Hey Vinay, what's up? So, basically, if I talk about the hey, welcome to the batch. So today we are going to start the ISS protocol. So you came the good time. So already all the OSPF videos are there on the drive. I can send you the drive link to you, okay, at the end of the class.
Yeah. Fine, boss, fine.
Great.
Sarab, hi.
Okay, so
क्या हाल भाई?
ठीक ठाक.
चलो continue कर.
Okay, so let me tell you about the OSPF protocol, right? So if I talk about the OSPF protocol, in OSPF, if you guys remember that, first of all, I'll tell you what are the things are in the OSPF. We have something called as a packet types. Let me recap those things. Okay. We had a hello packet, right? We have a DVD packet. Then we have a LSR packet. We have a LSU packet, and then we have a LSA acknowledge packet. Now, you may have a question why we are again recapping the OSPF protocol. To understand the ISS protocol in a good way, okay, you need to first know the OSPF, right? So OSPF have this kind of packet. If I talk about the OSPF states, right, we have, if you guys remember that we have a downstate attempt was also there, but it was used in the NVMe network. So right now we are not using the NVMe network. Ignore it. Init state, then we have a two-way state. Then we have start, right? Then we have exchange.
Loading full.
Loading and full. Right? Now, how about the LSS type? Now, this is the beauty of the OSPF. We have LSS type is a router LSA. Right? Then we have a network LSA. Summary LSA. That's going to provide the communication between the SU.MARY, right? That's going to provide a communication between the two different areas, right? Then we have a ASBR summary LSA. That's LSA 4. That contains the
that will be for redistribution.
Exactly right. So this will comes in the external LSA. Then we have a LSA 6 that's called as MOSPF, which is not supported by the Cisco router. But when you're going to form the neighborship with a different kind of vendor, so this MOSPF LSA will be appeared in your Cisco router. So the log master will be appeared. So you can ignore those log masses by putting the command mospf ls ignore. And then we have a NSSA LS7, right? So
Yes,
basically,
yes.
these are the major types of LSA. It's not like that. Apart from we don't have any, we have a LSA is called the opaque LSA, right? We'll see that in the traffic. Don't worry. Now, so these are the LSAs we have. If I talk about the areas, right? I will look the areas part now. In areas, if I talk about in OSPF, we have a something called as a backbone area, which is reserved for the area 0. Then we have a normal area, right? Any area that's between the 1 to 32 bit range, right? It's called as a normal area. You can make a special type of area like a stub and totally stub to block some particular kind of LSA based on your requirement. Then we have an NSSA and totally NSSA. Now, these are the things, right? Apart from, if I talk about the filtering or summarization for LSA 3 and LSA 5, you can do on a ABR for LSA 3, right? And you can do on the ASBR for LSA 5. Now, these are the basics things that we have covered in last 20 days, right? Now, let's take example, the problem of the OSPF protocol. First of all, the OSPF problem is what? See, these packets are not a problem. If I talk about the packets, these are the basic things, right? These are that's going to carry the information about the OSPF protocol. Again, these are not a big problem because these are the steps that OSPF needs to follow to exchange the LSAs. The problem over here, LSAs. You know, first thing about the OSPF, if you want to learn the OSPF protocol, you really need to know about all this protocol, all these LSAs. To learning this LSA is a critical task for the network engineer. It's very critical task. First, you need to learn this all types of LSA, and then what? Then you need to troubleshoot these LSA. And troubleshooting these LSAs, again, it's a very critical part. You need to find, okay, where is the route LSA is coming, where the network LSA is going, who is advertising the network LSA, who is advertising the summary LSA, who is not advertising the, like, PSBR summary LSA. So these are the kind of things that you need to follow in the OSPF. Now, again, if I come to the area part, in the areas, what happened? We have a backbone area. It means that area 0 must be there in your network. For example, if you have this, for example, this is my router number 1, this is my router number 2, and this guy's area number 1, and we have a router number 3 and router number 4, and this guy in the area number 2. You cannot provide the communication between these two areas. You need to have a area 0. So you need to have an area 0. That's my RX6 and R7. Through this area 0, I can provide the communication between the two different areas. If you want to provide the communication between the inter area, between the area number 1 to the area number 2, your traffic must go through by the area 0. So area 0, it's my transit area, right? You really need to have an area 0. If you don't have an area 0, you cannot provide the communication. And this is the backbone area. The major problem of this guy is what? You cannot make another area as a backbone area. I cannot say that area number 1 is a backbone area. I cannot say that area number 2 is a backbone area. And that creates the biggest scalability issues. Second problem, if you want to make a more scalable if your network, right, you need to manually configure this part. And to manually configure this part, what happened? If you guys remember that we have something called as an E flag in this stuff. So if you want to configure one router, if I'm going to configure router number 1 as a stub, right, then you need to configure router number 2 as a stub. And then again, if R3 is a part of the same area, then you need to configure the router 3 as a stub, because this guy's going to send the E flag. This also has to send the E flag. If this guy is going to send the E flag, this also has to send the E flag. So if you want to configure stub, you have to configure in the complete area to exchange the E flag. And again, that's create a problem. Can you imagine that? What I told you in the OSPF classes, if you like it's a recommendation, you can have 50 to 60 routers, right, in a single area. But again, this is just a theory part. It's totally depend on what? It's totally depend on your hardware. It's totally depend on your memory. It's totally depend on the CPU. How many LSAs, how many networks you have. So based on that, you can put the routers in an area. Can you imagine that if you have a 50 routers, on all 50 routers, you need to configure the stub. And somehow, right, if you want to block the LSA3, you need to configure the totally stub over there. Again, these are my manual configuration. Again, guys, I'm not talking about the benefits of the OSPF right now. We are just talking about the problems with the OSPF. What is the problem with the NSA? And second thing about the stub, right? The stub cannot become a transit area. Another, if you see the NSA, in NSA, what happened? You can have a ASBR, right, in the NSA area. You can have a ASBR in the NSA area. But again, NSA area generate the another type of LSA. That's LSA7. Again, you need to spend so much time on the NSA area. And NSA area create a suboptimal routing, right? If you guys remember that, we have seen the concept is called as a forwarding address, right? So NSA area create a problem with the suboptimal routing. And to avoid the suboptimal routing, we have a concept is called as a forwarding address. If you guys again remember the translation concept, if you have a router 2 and router 3 is both have the ABR, then who has a router ID is higher, will do the LSA7 to the LSA5 translation. Again, you need to think about it. Which router I have to make the translation router? If you have a wrong choosement, then what happened? You may face the suboptimal routing and maybe asymmetric routing too. Your control plane traffic will go via some way, and your data plane traffic will go via some way. Now, the third problem, another problem, if you see the OSPF, you have a limitation of the OSPF is what? You can do the filtering of the summarization of the LSA3 and LSA5 only on the ABR or ASBR router. These are the problems that we have in the OSPF protocol. Again, apart from this thing, when you gradually see the ISS protocol, you will see how many problems with the OSPF. Because of this reason, right? Because of this reason, in my tier 1 ISP and tier 2 ISP, right, it is not recommendation to run OSPF protocol. So that's our biggest issues, right? It's not recommendation to run the OSPF protocol. It's always recommendation in the tier 1 and tier 2 is the ISS protocol. If you're going to run the OSPF in the tier 1 and tier 2 ISP, can you imagine that how many routers you have? It's a huge router in the thousands. On a thousands of router, you need to identify, okay, I need to make this guy as an ABR, I need to make that guy as an ASBR, I need to do the summarization on that router, I need to do the LSA filtering on that router, I need to do the LSA translation on that router, I need to make that guy as the area 0, I need to create the virtual link. It's a huge problem. It's not recommendation to enable the, see, again, there is a two terms, it's a mandatory and recommendation, right? Recommendation means what? It's a recommendation, don't enable the OSPF. Again, if your call, you can enable it. But if you're going to enable it, you need to think about all those, problems. Now, so you may have a question, okay, these are my problems. To avoid this problem, should we have introduced the ISS protocol? No. It's not like that. You know one thing, ISS was a first link state routing protocol. It's a first link state routing protocol. It's not a second one, right? After the ISS, right, OSPF comes in the picture. Now you may have a question. So if the ISS was the first protocol, right, and OSPF was the second, then why OSPF become the popular? Nowadays, people don't like the ISS protocol. Not nowadays, of course, like 10 years back, if I talk about 5 years back, people have no idea about the ISS protocol. And people don't want to learn about the ISS protocol. But nowadays, every single where, man, I'm telling you, everywhere. If you go to the data center, in an ACI, you are running with the ISS protocol. If I go through the SDA access, you are running with the ISS protocol, right? If I go through the what we call service provider network, you are running with the ISS protocol. So if I talk about the enterprise network, we are running with the ISS protocol. See the requirement of the ISS. In a DC, we are running SD access, we are running SP, we are running enterprise, we are running the ISS protocol. So if you're learning the ISS protocol, you think about all this perspective. If your concept of the ISS is clear, you can deploy ISS every single where. But again, what I told you that OSPF second, ISS first. But again, OSPF become the popular. The reason was mistaken. Do you know what was the mistaken of the EIGRP protocol? EIGRP was a Cisco proprietary. That's a biggest mistake by the Cisco, right? In 2016, in 2016 or maybe the 2013, right? If you check the Wikipedia, let me show you that. I think so. In 13 they proposed and 16 they launched the RFC. Okay, so 13 they made this in the proposal, right? And in the 16 they launched the RFC. But this protocol was came in the 90s, and this was the amazing protocol. But the problem with the Cisco proprietary, again, it was not become the popular. The reason the OSPF become the popular was this OSPF protocol was only introduced for the IP. Only introduced for the IP. And that's why I like to show you something over here. If you go to the GNS3, run GNS, I can make some lab over there, or maybe I have a, okay, leave it this one next.
Actually, ISSs also have a plus point for IPv6, which is very famous nowadays and very
I'm coming to that.
popular. Yeah.
I'm coming.
That,
yeah. That's what I'm saying. That learning the ISS is amazing, man. People don't like to learn the ISS because of the.
it's not like that. We really love it.
I really love it. That's what I'm saying. That EIGRP was introduced, right? They have automatically the feasible successor concept, right? OSPF, right? FRR came in the 2008. So can you imagine that how EIGRP was an awesome protocol, but because of the Cisco proprietary, EIGRP didn't become the problem. So if you see, if I'm going to put the command router OSPF, have a look over there. What error master they can say that? You cannot run the OSPF protocol without IP. That's why OSPF is a pure IP-based protocol. It's pure IP-based protocol. Again, I'm telling you, ISS was the first link state routing protocol. OSPF was the second link state routing protocol. OSPF was for the IP. ISS, right? IP means what? I'm talking about the TCP/IP protocol. TCP/IP. But you know one thing, this was the biggest mistake of the ISS. ISS protocol was not launched for IP. It was for called as a CLNP protocol. CLNP is for the OSI, not for the TCP/IP. So ISS was designed for the OSI, not for the TCP/IP. On that time, in 90s, 80s, if I talk about, in 90s, 80s, IP was not dominant protocol. IP was not dominant. Nobody has idea about the IP. Everyone know about the CLNS addressing. Every single person. IP was not a dominant protocol. CLNS was a dominant protocol on that time. And every single way, if you want to give the addressing to the PC, you were giving the CLNS. If you want to give the addressing to the router, you were giving the CLNS addressing. Nowadays, you are giving the this PC, okay, this is the 1.1.1.1. This router is the IP address is 2.2.2.2.2. This is the IP, right? But on the time, on the CLNS, we are giving the like that way. For example, 2.1.2.2.4.A.7.D.3.9, say something. That's a CLNS addressing. So at the beginning, they introduced CLNS for the OSI. But the problem of this addressing mechanism is what? This addressing mechanism has a problem. The problem of this addressing mechanism is what? They are not in the fixed length. And if the addressing is not a fixed length, then what happened? Can you imagine that if you have this kind of network in normal IPs, if you talk about 192.168.1.0/24, 2.0/24, 3.0/24, you can have ability, you do have ability, you can summarize this network into the single one. How? I can say that, okay, let's do it, 22. But the problem with the CLNS, right? The problem with the CLNS, you cannot do summarization. Now, can you imagine that if you have a 20 host, just a 20 host, I'm talking about, forget the, I'm talking the millions right now. You are still in the 90s, 80s. Pay attention right now, where you are still in the 90s, 80s. On the 90s, 80s, if I'm going to do the summarization for the CLNS, you cannot do that because a structure, if you see, it's totally different. To do the summarization, your bits should be matched. Your bit should be matched. Remember the summarize how we did the performance summarization? Bits has to be matched. But in the CLNS, bits are not matching. It's a different bits we are using. Second problem with the CLNS addressing is what? Right? You cannot do multi-homing. You can do that, but problem is there. And because of this two major problem, what happened? Itself in 90s, 85, right? What happened? Gradually, people are acquiring or deploying the IPs in the network. So starting, it was OSI, right? Then TCP/IP, same like I can call it CLNS. Then we have IPs. So starting was this was the starting. The protocol was for this was the ISS protocol, right? So ISS was handling for this one. It was the first protocol of the link state routing protocol. But later what happened? They finalized that no, ISS is only for the CLNS. They introduced the OSPF protocol. But again, OSPF has a lots of disadvantage, right? Scalability issue. Then finally what happened? In 90s time, right? Is 90s time, they found that CLNS has a lots of issues, right? And ISS was only for the CLNS. They introduced the new type of ISS. It's called as a dual ISS protocol. They introduced the new types of ISS. It's called as a dual ISS protocol. Why I call the dual? Now this ISS protocol we can implement for the CLNS. Again, we are still in the 90s right now. People were using the CLNS, and we can use for the IP2. It means that I can use the ISS protocol for the OSI. At the same time, I can use the ISS protocol for the TCP/IP protocol. That's how, the history came. What people are thinking for the ISS right now? Okay, ISS is a recently new protocol. OSPF first came. No, the first link state routing protocol is the ISS protocol. And later on, they introduced the call as a dual ISS. It is also known as the integrated ISS protocol. Integrated means what? We can use the same ISS protocol in the both environments. So you can, ISS can run for either you can run the CLNS or IP2. And the first RFC was introduced, it was a 1195 of the ISS protocol. And finally, people are gradually deploying the ISS protocol in the market. And now it become the de facto in the company's network, the tier 1 and tier 2 networks, because of the features. What another beauty of this feature, if you compare with the OSPF protocol? If you see, OSPF is a pure IP, or we can say the layer 3 protocol. But ISIS is a layer 2 protocol. So if I talk about the security perspective, think about it. IP, right? Data 1, data 2. And this is the MAC is A, MAC B, 12.1 and 12.2. This IPs is connected to now the service provider. So normally what happens, this information, the 12.0 will be appeared in the service provider network. So if any attacker is sitting over there, they can easily perform the attack in this network because they know the routes, right? That's how we advertise the routes in the OSPF protocol. But if I talk about the ISS, how? ISS is a layer 2 protocol. Are you sharing this MAC address to the ISPs? No, you are not sharing the MAC address to the ISPs. So if the attacker wants to perform the attack in the ISS network, then what happened? This guy has to be physically connected, right? This guy has to be physically connected in your network. Then he can do the attack. Otherwise, he cannot. So ISS is a pure layer 2 protocol, and it provides the more security. So if any attacker wants to perform any kind of attack, then attacker should be physically connected. Again, let's back and revise the same thing. What I told you that, come on, 1 minute. Yeah. So these are the problems that we have seen in the OSPF, like LSAs, areas, and then we have the filtering of these guys, right? And then what happened? We have seen that ISS protocol and OSPF protocol. OSPF was the first link state, not second link state routing protocol. It was popular because of the IPs. ISS was the first link state routing protocol. The ISS was not became the popular because of it was introduced for the OSI, the CLNP protocol. The addressing mechanism was the CLNS, right? CLNP was a dominant protocol on that time. IP was not a dominant protocol. But the problem with the CLNS is what? You cannot do the summarization and you cannot do the multi-homing in the CLNS, right? But with the help of IP, what happened? You can do the summarization, you can do the multi-homing too. So that's why what happened, people are gradually picking the IP, and now in the market nowadays, IP become the dominant protocol. Previously, IP was not a dominant protocol. CLNP was a dominant protocol. Then what happened? We have seen that ISS for the OSI model, CLNS like a addressing mechanism. OSPF was a TCP/IP. OSPF is a pure layer 3 protocol, right? And anyone can perform an attack in the layer 3. But if you compare with the ISS protocol, ISS is what? ISS is a pure native protocol. If the attacker wants to perform the attack, they has to be physically connected. But in the OSPF protocol, what happened? Any remote attacker can do the attack. Any remote attacker can do the attack. That's the biggest issues of the OSPF. Right? But this guy is a beauty. Attacker cannot jump to your, if your attacker comes to your network, it means that your security guard is not a secured way, right, to preventing it. That's how the history comes in the picture. Guys, questions? Adnan, Sarvjit, Vinay.
So I understand these are one of the pros and cons. So we can say these are the pros as compared to when we compare IS and OSPF. Are
These
there
are the
any other
major pros.
factors? Or they are the major one. Okay.
Yeah, these are the major one.
Okay.
Okay, we haven't come to right now. We have to see the lots of things, but these are the major one. And these are the histories that we have seen.
That's great. Okay. Thank you.
All good?
Yep.
Now, but do you know one thing? Still, if you want to run ISS protocol on a Cisco router, right, you still need to give CLNS addressing. It means that it's a mandatory. You understood? So ISPF, sorry, ISS, as I told you, it's a layer 2 protocol, right? But you really need to give the CLNS addressing. If you don't give the CLNS address, then ISS, you cannot run the ISS on the Cisco router. Right? That's you really need to take care of it. If you don't have a CLNS, you cannot run the ISS. Now, how we can give the CLNS addressing? See, normally people give the different name of the CLNS addressing. We'll talk about that name as well as, right? So the first name of the CLNS addressing is called as a AFI, Authority Format Identifier. That's a first value, AFI. The second value you have a area ID. Same like your OSPF area ID, nothing is difference. Okay, same like OSPF area ID. Only the difference I can say that over here. In OSPF, you normally give the area ID in the decimal format, right? And you can give in the dotted decimal format. Like that, area, I can say the area 0 and area 0.0.0.0. Here you can define the area ID in the dotted decimal format. Third part you have is called as a system ID. This system ID you can compare with your router ID of your OSPF. And the last, we have a N selector. That N selector is just gonna tell you this mechanism that we are doing the ISS protocol is for the router, or we can say the network layer. That always set to 0, 0, always in ISS. If you put the any other value, the command will be rejected. The 0, 0, it's represent that this value is representing that is the network layer. The first AFI value that I like to give over there, it's 49. Now the question, why P49? Why not the other values like a 47, 48, 46, 34, or 100, something like that? The reason is that you can use those values as well as 47, 38, you can use it. But in the production, if I talk about, you always find the 49. The reason this AFI is reserved for the private use. This AFI we are using for the private use. Same like your RFC 1918 addresses. We have a concept of the public address and the private address, right? Same like that, we have a AFI 49 that's only used for the private use case. Let me show you one thing over here. What I can do, this PC, and I can open the speed books. I think so. This one I have, yeah. This one. Hold. Sorry, I was talking on the mute. So I say that this is the one of the book that I used today for the ISS protocol, right? But apart from this book, I have a lots of ISS protocol book, right? But eventually at the end of the day, this book will be finished. Okay. So, addressing integrity, right? Yeah. So if you see if so these are the A5 values we have. I can use go for the 37, that's used reserved for the X121, 39 used for the ISO DCC, 41 is for the FC. So these are the different organizations, right? It's a name of the organization. They are using the different values for the ISS protocol, right? Authority format identifier. But the one of the local values is reserved for the 49. In a production network, always you find the 49. Like personally, I tell you, I have gone through the multiple, like almost 30 plus productions networks, like the service point networks in my career, right? And I've seen that everyone is using the 49. Even if you go with the, like if I talk about the CCIE lab exam, right? Everywhere is 49 is coming. So the 49 is recommendation to use for the local use case purpose. You can use the different as well. You can use for the 47 as well as and 45 as well as. But what happened if some other engineers will come and they do not have any idea, right? What is 47, 45? Because normally people are used to know about the 49. So they may get confused, right? So it's a recommendation to have a consistent same value on every router. Then next part, we have a area ID. As I told you that here, the area ID, you can use anything. I can use the 0, 1, 2, 3, 32-bit number. I just say that right now 000. That's my AD ID. Then we have a system ID. I can use the 111. That's a format of giving the system ID. Again, this system ID you can correlate with the router ID of the OSPF protocol. Right? AD ID, same like your OSPF AD ID. And just for your hack of things, I can say that this AFI you can consider is a RFC 1918 address, public and private. So private use case. And this N selector you can compare like a ether type value of the what either you can call the ether type value, or either you can call as a protocol number on the OSPF protocol. So I can call as the ether type value on the layer 2. Like 0x0800, right? 0x08006, right? That's value. So always it should be the 00. So this is the way that you can configure the CLNS addressing. This CLNS addressing, people has give the different name, right? Sometimes people call this guys AFI values, the complete format. Sometimes the people call it the CLNS addressing, right? Sometimes people also call it the NSAP address, network service access point.
The NSAM, network service
access point. Network service access point. CLNS you can call as a classless network services.
Yes.
So again, the different people has like we have this 1 or 0 or 0 or 0 or 0/8. What you're calling in the static routing you can call as a root. In the RIP you can call as a root. In the EHRP what you can call as a prefix. If I talk about the OSPF, you can call as a LSCs. In BGP you call as a NRY. In ISS protocol we call as LSPs. Same that people give the different name for this word. So this address is a mandatory address on your router. Without this addressing mechanism, you cannot run the ISS protocol on the Cisco router. Again, just like point of this thing, this one and this one, the attacker has to be remotely connected. But in the ISS, the attacker has to be physically connected. Remotely connected attacker cannot do the attack in the ISS, and it's a layer 2 protocol. So of course, overhead is very less because of layer 2 protocol. Overhead is very less. You can compare with the same thing in the MPLS, right? MPLS is the layer 2 protocol. So less overhead is happening on the Cisco router side, right? Same thing. And these are the CLNS addressing. Now, let's compare with another part. So this I just gave you the hack of basic info. Now let's come to this part, OSPF. As I mentioned that OSPF protocol is for the TCP/IP, right? And ISS protocol is for the OSI, right? So terminology is a little bit different. For example, here we call as an interface. Here we call as a circuit. Right? Here we call as a LSCs. Here we call as a LSPs. Here we call as a DR. Here we call as a
DIS.
We don't have a backup DIS over here. We'll see why we don't have.
That's true.
There is a reason not to have a backup DIS. I'll let you know. Don't worry. Another difference. We have a lots of packets. So I'm not going to talk about the packets. Forget that packets information, right? Now, another thing about that. Here we call as a router. Here we call as a intermediate system. The meaning of intermediate system is called as a router. Here we call as a host. That's your PC. Here we call as a end system. These are the basic difference. Hold on. Wait for some more time. You will see the more and more difference when I'm gonna like come to the CLI part. But these are the basic terminology that you have to take care about it. Same like that, the spanning tree protocol. The spanning tree protocol was not introduced for the switch. It was introduced for the bridge. That's why most of the terminology in the spanning protocol start with the bridge, like a bridge ID. Root.
Yes.
Same thing, ISS was for the OSI, right? Later on, we have introduced the dual ISS, or we can call it the integrated ISS. But still, terminology, we are using the older. Right? Now, in ISS protocol, this is the most important point. Have a look. In ISS protocol, we are allocating the complete area, not complete, not like that. So in ISS protocol, in OSI protocol, we can allocate one interface to the different area, right? And another interface into different area. But again, if you guys, this statement could be wrong. If you guys remember the last class, we seen that multi-area concept, right?
Multi-area, yeah.
So just to tell you, so in that one, we have allocated the one interface as a part of the two areas, right? So forget that one. If I'm not going to ignore that RFC, right? So take example, this is router one. I have a two interface, the F0/0, F0/1, and we have F0/2 as well as. Okay, so let me write on F0/0, F0/1, F0/2. You know this guy. Let me copy and do the same thing over here. Copy and paste over here. Now, I can make this guy as a part of area 0. I can make this guy as a part of area number 1. I can make this guy as part of area number 2. In OSPF, you do have ability, you can allocate one interface to the different area and another interface into the different area. But in ISS protocol, the whole router represent a single area. Whole router means what? I can say that the complete this complete router, doesn't matter how many interfaces we have, all the part of the area 0 or area number 1. See think about the scalability perspective. Can you form the neighborship in OSPF like this way? Is it possible? Is it possible to form the neighborship like this way? No, we cannot do that. But in the case of ISS protocol, I can say that this particular router, doesn't matter how many interfaces they have, it's area 1, it's area 2, we can form the neighborship. We can form the neighborship. So the complete router itself is representing a one area. Another point I also may mention over there, that's another difference. In OSPF, network type, if I talk about, we have our broadcast, which is default on the Ethernet segment. We have a point-to-point, which is the default on the serial link. We have a point-to-multipoint, and we have a non-broadcast multi-access. 4 types of network we have. 4 types of network we have in the OSPF. But if I talk with the ISS protocol, we have our broadcast and point-to-point. Only 2 types of network we have. Now, let's go into more detail of the ISS. So I hope the basic funda is clear to you guys. What is the ISS protocol now? So ISS is also a linked state routing protocol. Same concept. They have a digicast algorithm, right? Same, they have a LSDB table, but in the ISS we call as a LSPDB table. I'll let you know why we call as a LSPDB table. Don't worry about that. But let's focus on the basic part. As I told you that in OSPF, if you want to deploy the OSPF network, you need to know all the information. You need to know all the types of LSAs. You need to know what router should be the ABR and what router should not be the ABR. You have to this thing predefined. And then you have to deploy those things in the network. But in the ISS, it's totally different. ISS works on label concept. Two types of label we have. Normally people are saying the 2 types, even the RFC is giving the 2 types, books are giving the 2 types. But if I talk over from my end, it's a 3 type. But let me mention the 2 types only. We have a label 1 and we have a label 2. So I can say the label 1 router and label 2 router. And another type of we have is called the label 1 and 2 router. Label 1 and label 2 router. Three types of, not 3 types, so we can call it the 2 types only. This is the default behavior on the Cisco router. Hold on, right? You will get to know that why it's default behavior. Why not the label 1 is the default behavior? Why not the label 2 is the default behavior? Have some patience with ISS. You will get to know each and everything. You can change this label globally. It means it change for every interface. You can change this label as an interface. This is as well. So it's up to your part. How you're gonna change. If you change the globally, you can change the globally. If you change the interface label, you can change the interface label too. If you understand this objective, right, your ISS almost finished. What I can do, let me show you this part. I do have a lab set up. I need to close this lab and I have ISS protocol and somewhere, not this one, not this one, not this one, not this one. Yes. So you can see that I have a label 1. Let me do one thing. Let me capture this one and put it over there in the paint. you can see that, as I mentioned, that we have a types of label, label 1 and label 2, right? Label 1 and label 2 as well. That's a default one. So I'm gonna make the router as a label. So the complete ISS works on the label concept, right? So for example, I can say that this router 1 is a label 1 router. This router is also a label 1 router. If the label will be matched, right? If the label will be matched, they can form the neighborship. This all concept right now I'm talking about the, right? This all concept that I'm talking about right now in the single area and multi-area concept as well. So first, let's have a look on the single area concept. In single area, how the things are working. These are my label 1 router. This is my label 1 router. They are the part of the same area. Can you see the same white color is there? The box. It means that they can form the neighborship. Right? They can form the neighborship. The neighborship will be over here. It's called as a label 1 neighborship. The neighborship will be over here. It's called as a label 1 neighborship. Same thing if you see the same area, guys, over here. Here we have the default behavior of the router is the label 1 and label 2. But as I told you that you can change it if you want. Another type is a label 2 router. The neighborship over here, you will see as a label 2 neighborship. I'll show you how the things are going to work. Don't worry about that. I'm just giving you the basic information right now. I'm just making you the, I'm just making you the familiar with the, terminologies. The neighborship over here, it's come as a label 2 neighborship. The reason I have a label 2 router over there. This is the label 1, label 2 router. So he will send the label 2 hello packet to form the neighborship. And he will send the label 1 hello packet and the label 2 hello packet. Then what happened? This router cannot understand the label 1 hello packet. This router can only understand the label 2 hello packet. So that's why he will form the label 2 neighborship. If I talk about over here, what happened? He will send the label 1 hello. He will send the label 2 hello. At the same time, he will send the label 1 hello and he will send the label 2 hello. It means that you will have a 2 neighborship. You will have a 1 neighborship with the label 1 and another neighborship with the label 2 neighborship. Same way over here. You will send the label 2 hello packet and label 2 hello packet. So you only have a label 2 neighborship. If you see over here, it's a label 1 and label 2 router. It's a label 1 router. So he will send the label 1 hello packet and he will send the label 2 hello packet. But he will only send the label 1 hello packet. So when this router is sending a label 1 hello packet to the router 7, what happened? He can only understand the label 1. He will reject the label 2 and form the neighborship with the label 1. Because this label 2 packet cannot understand by the router 8, right? This label 2, because router 8 is not running with the label 2. So the neighborship will becomes over there label 1. Same concept over there. Can you see that? Same concept over here. He sends the 2 types of hello packet, label 1, label 2. The router 10 is only understanding the label 2. The neighborship is the label 2. These all part of the single area that we have seen. Now, if I talk about the double area, or we can say the multi-area, why we are requiring the multi-area? Just maintain the scalabilities. To make a ISIS flexible, we are using the multi-area concept so that the load will be decreased, right? Configuration will be decreased. SPF algorithm will be decreased. So if you see, we have 2 different areas over there. Listen to me carefully. Between the 2 different areas, you only have label 2 neighborship. You will not have Okay. Okay. So hold on. I need to recap this one. Yeah. So between the two different areas, you only have a label 2 navigation. So can you see that what I have configured over there? Label 1 for the area 0, label 1 as area number 1, two different areas. I only form the label 2. So in that case, do you know what happened? You will not have any neighborship over here. But have a look at the same thing. I have a label 2 router and I have a label 2 router, two different areas. You will have a L2 neighborship. So the complete ISS protocol, right? The complete ISS protocol is works on the labels. You have a proper planning for the labels. If you're, it seems like, we can call it, you are planning for the ABR and ASBR, which should be the back one, which should be not back one. Seem like that you have to do, but that is not complex like that in the OSBR. It's a very simple. Okay, this is the label 1 and label 2. That's all. But again, by tomorrow, you will be expert in this labels, how these labels are working. Tomorrow, when I'm going to show you the lab, then you will understand, okay, how the things are going to working over there. Now, if I talk about the configuration,
router पे नजर मार दो.
did you say to me, Brian? Subject?
Sorry. I was just
okay. So if I talk about the configuration, right? Configuration is pretty simple. A very simple configuration we have in those. Sorry, ISS protocol. On the IS router, if I talk about the configuration, like what you have to do, you need to go on the router and say the router ISS protocol. Just hit enter over there. This is the one way to configure it. I say the net address, the network entity title. As I told you that you can define the different name for this guy. Some guys say the net address, some guys NSAP address, some guys are CLNS addressing as a net 49. That's for use for the private. See the area. Then that's a system ID, called as a router ID, and the end selector always be 0. That's all. The default behavior is what? It's a label 1 and label 2. Leave it. I don't have any issues. And you just need to go on the interface and say that IP interface, right? And I say the IP router ISS protocol, right? This is the one way. Second way, what you can do, same iOS router, I can see the tag value over there, CCIE. Here I haven't defined any tag. So if you don't define any tag, so by default, the tag will be the null. If you don't define any tag, by default, the tag will be null over there. I just define a tag over the CCIE. So if I define the tag over the CCIE, you need to call the same tag over here. The same tag you need to define over here. Right? This is the IOS configuration. Again, this part is known as a AFI, authority format, and this part is known as the area ID. This part is known as a system ID. And this part is known as a end selector. Same thing, this is the null. This is just a tag value that I have defined. Okay, one more thing. In the last batch, so some guys say that this is like a Cisco EIGRP named mode. It's not a ISS named mode. Named mode is only in the EIGRP protocol. We don't have a name mode in the OSPF and ISS protocol. It's just a tag. The name, the process, you can call it. right? This is the normal IS configuration. Very simple. You just need to go under the IS interface and enable the ISS. But if I talk about the XR, is little tricky. How? In the XR, what happened? I said the router ISS, you don't have an option. You don't have an option to enable like a null. I cannot say like this. I cannot put the enter over there. What you have to do, you really need to define the tag over there. Without tag, XR not going to work. It's mandatory, I can call it. Same concept. After that, what happened? I need to tell this guy, hey, you know one thing, because XR does support for the multiple address families like IPv4, unicast, multicast, IPv6, unicast, multicast. I can say that, hey, you know one thing, I run the ISS protocol for the unicast. This command I have enable IPv4 unicast globally. That's the first. You need to enable it. I need to tell this guy I'm enabling this protocol for the IPv4 unicast. Then after that, what happened? I need to tell this guy, hey, let's define a net address. 49, same 000 area ID, system ID, and the N selector. And then once we have done this thing, again, leave the part of the label 1 and label 2 right now. The default is a label 1 and label 2, right? The default is a label 1, label 2, leave that part. And then I'll call the interface 0/gig0/0/0, right? And IP, that's all. And then say the address family, IPv4 unicast. Enable the ISS to the interface. So little difference here. I'm not enabling the IPv4 unicast. The reason is that because IPv4 unicast is by default enabled. It's by default enabled. But in the XR, by default, the address families are disabled. That's why first you need to enable the address family in the global configuration for all the global command. Global command in the sense of what? For example, hello time, hold on time, LSP's time, right? Maximum path, all those things. But I also need to tell this guy, hey, you know one thing, this interface, because on this single interface, you can configure the IPv4 address and IPv6 address. So I'm telling this guy, hey, you know one thing, on this particular interface, I'm going to enable the IPv4 ISS protocol, not the IPv6 one. So you need to enable the address family over there as well. If you don't enable it, it's not going to work. So only the basic difference is what? You can enable the ISS without tag. That's called configured as a null. And with tag, that's called as a ISS tag value CCIE. Default behavior is a label 1 and label 2. If you want, you can change to the label 1 and label 2, depend on the requirement. For example, right? I'll just give one small example. This might add number 1. This might add number 2. This might add number 3. This might add number 4. Okay, this might add number 5. This might add number 6. So what I can consider this data 1 and data 2, as I told you that here we are putting the complete router as an area, not the particular interface, right? So I can call this guy as an area 0000, right? So 49, that's my A5 and the area 000. So I can call like this way, right? Same way, I can call this guy 49 is the area 111. I can call this guy 49.2.2.2.2. If you see one thing over here, what? You know one thing, right now these are a different area, right? I can have a same single area concept as well as like router 1 and router 2 and router 3 like this way in single area, not a big issues, right? I can call this guys a area 2.2.2.2.2. But in this case, what happened? You need to design. In this case, I can make this guys a level 1, all level 1 and level 1. No issue. We don't have any issues. Either we can make a level 2, level 2, level 2. Or either I can make the what default one, level 1 and level 2. Anything I can make this. No issue. But again, later by days by days, you will understand which one you have to make it in the single area. But in this multi-area concept, you have to proper plan. Like this router is always should be the level 1 router. The reason is that because this router doesn't have any connectivity with the different area. It's called as a stub. And that's why this level 1 is called as a totally stub. It's behave like a totally stub. This is the level 1 and level 2. That's you consider as a ABR, because eventually this guy is providing the connectivity with the 2 different areas, this one and this one. I can consider this guy as a level 2 and level 2. Why I consider this guy as a level 2 and level 2? Because this guy is going to provide the connectivity, this level 2 area, not level 2, this level 2 router is providing the connectivity between this area and this area. So I can call this guy as a backbone area. So level 2 is known as a backbone. Level 2 is known as a backbone in the ISS protocol. Same you can consider is the area 0. But in the area 0 itself is a reserved. But in this case, this is the area 111, right? I can change to the 2222. I can change to the 333. I can change the 4444. Anything I can make it. Only the important part is what? The connectivity between the 2 different area has to be go by the level 2 router. And that's why I made the level 2 over there. And this guy should be in what? Level 1 and level 2. Because it's again ABR providing the connectivity that this area to this area. So again, it's a ABR. And this guy is in the level 1. Why? Because this guy doesn't have any connectivity with any other one. So totally stuck. That's how, again, that's I gave you the very fundamentals things today. Okay, don't worry when I'm going to do the practicals. Today, I just want to clear some basic concept of the ISS, right? What is the terminology of those things, right? So that from the day tomorrow, you will become the familiar with this terminology.
What if I'll keep all the nodes in L2? That will also work.
No, there's
right?
no issue. That problem will come over there.
What kind of problems?
This router is going to maintain the complete routing information. Right?
That's true. Then in that case, it will be something like I have kept all the nodes in area 0.
Area, so do you want to make all the 6 route in the area 0?
No. I mean the area in the sense like I'm talking about all routers will act as layered level 2 router.
Level 2 router. So what happened? For example, this 6.0.0 information you have, right? So this 6 information is going to maintain by the level 1 router. So sorry,
that's
router
true.
number 1. True?
Yes.
Okay.
Yep.
So what happened? The routing table will increase over there. LSPDB table will increase. CPU will be high. Memory will be high.
That will be the only problem. So non-scalable routers we can't go with that approach.
Because we
but if we have a similar kind of router which is not at all possible in a huge network, So that is why we have to use this L1, L2 and L2, L2 concept.
Right, buddy. So normally what you can say that in that way, I can tell you.
Yeah.
If you remember that we can manually configure it, area as a stub, right? In OSPF, we can
Correct.
manually configure as a totally stub. We can manually configure as a NSSA and totally NSA. Here we don't have a concept of that one.
Yes, since we don't have that concept, we used to keep
That's
it in
why the
L1
label comes
and
in the
that will
picture.
solve our purpose.
Exactly. That's why label comes in the picture.
Yeah.
Now, understood over here. The neighborship you will see over there, right? What will be the neighborship? He will send the label 1 hello packet.
That will be level 1
L1.
membership.
And this one also the label 1 and label 2 hello packet. Which neighborship they will form?
L1.
L1
L1.
neighborship, because he cannot
Yes.
understand the label 2, right? So the neighborship will be L1. Now he will send the label 1 hello packet and label 2 hello packet.
The router 2 will have two different tables. One is L1 and one will be L2. And if you talk about router 3, it will only have level 2.
Right, buddy. So in this case, what happened? Router 1 is going to send the 2 hello packet, L1
That's
hello
true.
packet, L2 hello packet. Router 3 is going to send the L2 hello packet. The neighborship comes over there is the L2 neighborship, because router 3
Yes.
cannot understand the label 1 hello packet.
Yes.
Benai, you are understanding all the point?
Yes, yes.
Great. So now over here, he's going to send the label 2 hello packet. And over here, he's also going to send the label 2 hello packet.
So both will have level 2.
So the neighborship comes over
Hmm.
here. It's a label 2 only. Right?
Hmm.
Now think about like this way. So router 4 and router 5. He's going to send the label 2 hello packet. And how
Similar like
similar
2, 3.
concept, right? Label 2. So this router cannot understand the label 1. So the neighborship comes over there. It should be the label 1. Sorry, label 2. Now the same behavior will be happening there. It's going to send the
And
label
R1 and R2.
and L2 hello packet. But this guy only can send the L1 hello packet. So router
Yes.
5 cannot not router 1, router 6 cannot understand the L2 hello
L2.
packet.
Hmm.
So that eventually the neighborship will be L1.
L1.
So if you see the complete network, right? So this is the ABR router number 2, that's going to provide the connectivity.
Don't we have ABR routers here? Do we call these routers ABR only in ISS?
We call this guy as an ABR router. L1 and L2 router is called as an ABR router.
But I haven't seen this term in ISS.
Don't worry, I'll show you that.
Okay.
Wait for the magic.
Okay.
Yeah. All good?
Okay.
So that's enough for the theory today, man. So we'll do the labs tomorrow. Okay, so the same lab I'm gonna first show you this one. Okay, it's gone. So not be. So where is that? So this labels, we are gonna do the labs tomorrow, right? And then we'll see that how the thing's gonna work. But you know, the main, you know, क्या बोलते हैं उसको मजा, जो मेन मजा जो आएगा ना, वो XR पे आएगा, क्योंकि like ISS डिजाइन किया गया यार XR के लिए, मतलब सर्विस प्रोवाइडर के लिए. So मजा XR पे आएगा, but ऐसा नहीं कि हम लोग iOS नहीं पढ़ेंगे. We are gonna learn the ISS too. Sorry, iOS.
Okay.
So पहले अपन क्या करेंगे, like what we are gonna plan for the tomorrow. So first we are gonna configure all this part. We understand the neighborship concept, okay, and then अपन discuss करेंगे like on the single area. We are gonna discuss on the iOS router. Then all the like a hello packet, whatever the packets we have, and like a DIS concept. That's an interesting one. All the kits we have in the ISS protocol, most of the people don't know. And whatever the hello packets we have a different hello packets. We have different LSPs. The most interesting concept is called as a TLV. उसमें मजा आएगा.
Correct.
So TLVs देखेंगे. Then we'll go to the maybe you guys have to wait for the one more weekend for the exam. But I'm telling you, you will become a fan of this protocol.
अदनान बाजी होंगे, मैं तो already हूँ.
Let's see if how it goes.
बाजी बिरयानी बची हुई है, उड़ा दी.
अभी तो खाई नहीं भाई. अभी तो
बिरयानी
इसके
बोल
बाद
बोल के
टाइम आएगा।
ना मेरा
बिरयानी
मेरा
टाइम
मेरा
इज इन द
हाँ,
नेक्स्ट 30 मिनट्स।
मेरा मतलब मूड खराब कर दिया। मैं डाइटिंग पे चल रहा हूँ आजकल और
ओह
तो
डियर,
बिरयानी बिरयानी
ओह
कर रहे
नो।
वही मैं कह रहा तेरे को, जब खाना ही भाई वही है तेरे को,
हैं।
हरे
मुझे
पत्ते बापू।